Thanks, Michael. So I just realized that I did not put in a slide about who I am or how to contact me. So my name's Anita Kuno, and my Twitter nickname and my IRC nickname is Antea, A-N-T-E-A-Y-A, if you want to find me on IRC or Twitter. You're more than welcome to do that. As Michael said, I work for HP, and I work upstream on OpenStack. So we're going to talk about when you are a developer contributing to OpenStack and some of the common trip hazards. So this isn't a getting started with OpenStack talk. But in the infra channel, where I try to help out with, although I'm currently on another project right now, but there are a lot of common questions that people kind of trip over, and we try to document them as best as possible, but they're either hard to document, it's a brand new feature, or it's something that even though we document it, people don't seem to understand what we're trying to convey. So the title for this talk actually came from somebody who is a very prolific contributor, and he was looking for something, and we showed him the URL and said, here it is, here's the full package, and his response was, how did I not know this? So thank you to Hubcap for giving me the title of the talk. So some of it's basically a grab bag of things that might help you as you contribute to OpenStack. So just in terms of getting a sense of who's in the room, we've established that the majority of people know what OpenStack is. Is that correct? We know what OpenStack is. Okay. How many people have contributed a patch to OpenStack, have offered a patch? Okay. About a third, maybe half of the room. Okay, so some of the things might be helpful if you do decide to get started with OpenStack as a contributor, and some of the things that I mentioned, if you are or have contributed, might be helpful as you go along. So I'll start with an OpenStack infrastructure overview. I will warn you, this slide is kind of bright. So there's one thing I will say. I used this slide yesterday, and it was right yesterday. John's already ahead of me on this one. I thought, last week when I was making it and I was enjoying putting everything together and so on and making sure everything lined up, and I thought, oh, it's perfect. This will be the slide I can use for a couple of months anyway. So I used it yesterday and it was correct, and today it's wrong. And you will see that there are 3 Jenkinses represented. And yesterday we had 3 Jenkinses, and today we have 5. Are they serving and running jobs?
They are operating within normal
Yay!
parameters.
So that's the speed of how fast our test infrastructure team works. Morning Australia time, evening North American time, there was a problem between Jenkins and Nodepool in terms of communication. And so the problem was assessed, and Jim was up early this morning, and I was watching the conversation evolve. And so the assessment in terms of what was happening and so on. And the evaluation was that our Jenkinses were having to deal with too many jobs at once, which is a common problem that we keep hitting. And so the solution was to spin up 2 more Jenkinses. So between, I guess that was probably about 6 o'clock this morning, I saw that conversation starting, and now, what are we, 3? So what is that, 8 hours, 7, 8 hours? We have been able to spin up 2 Jenkinses, get them configured, and have Nodepool serving them VMs, and actually have them so that they're now able to run jobs. So I thought I'd share that with you. I'm pretty impressed. So anyway, we'll go over this graphic quickly. So you, on your local development as a contributor, you are the red oval. You push up your patch to Gerrit. Are we all familiar with what Gerrit is and what it does? Wonderful. Yes? Okay. It's essentially a fancy Git repo. So it has the canonical Git repos of all of the OpenStack projects that Gerrit knows about, and there's some fancy things at the front which we can configure in terms of how do merges happen and who has permissions to do various things. So, and then Gerrit communicates with Zuul, Zuul communicates with Gearman. Gearman communicates with all of the Gearman workers on Jenkins, and we put in the Gearman layer so that we could have more Jenkinses. And because we have that, the decision from spinning up 2 more Jenkinses to actually having them took a matter of hours. So we already had that in place. Node pool is a tool that was written internally in order to be able to serve up VMs. So node pool has VMs, those are the stars. It is assessing how many spare VMs are available in reserve for each Jenkins. I'm seeing some interest in this, so I'll go into it in just a little tiny bit more detail. Node pool, once every 24 hours, takes all of the current dependencies, downloads them all, and caches that, creates a snapshot, and then uses that snapshot for the next 24 hours for any VMs that it spins up. In a 24-hour period, we probably spin up 400, 500 VMs. More than that? 500 VMs in 24 hours? We'll go with that. I'm probably wrong, but let's use that as a figure. And then 24 hours later, node pool goes through its whole session again. Node pool will serve up VMs in reserve for each Jenkins. And so now it does 5. And then when Jenkins actually has an assignment and a job to run, it will go into its reserve, and it will select a VM, and it will attach itself and run the job. And then the logs get moved over, the VM goes down, node pool will spin up something else. And then the message that contains the URL for the logs goes back through Gearman to Zuul to Gerrit and gets attached as a comment to the patch that it just tested. Does that make sense, or have I been very confusing? Okay, it makes sense. Okay, great. So that is how our infrastructure, basically that's our workflow. And knowing that, as a contributor, that will help you because when something happens to your patch, or when you get a comment back, or when you go looking for the logs and the logs are lost or missing, knowing that might help explain why some of those things are taking place. Status.openstack.org will be very helpful as a URL for developers, because there's many handy tools on status.openstack.org that helps you to assess what's going on. If you know what's going on with the current infrastructure in terms of flow, then you understand where your patch fits in. And if you're experiencing, if some logs came back and you don't understand the message, it may help you understand if there's a problem with your patch, or assess what's happening with the infrastructure system. Zuul has a status page on status.openstack.org, and that's what it looks like. And unfortunately, that's pretty small, and I'm sorry about that. But hopefully, oh, I don't have any clock on my slideshow. Can you wave to me when I'm done? Thanks. So basically, if we'll take a look at it this way, you'll see 3 columns. The 2 columns to get used to are the check column and the gate column. So this is the status. When I took this screenshot, these were all of the patches that were going through the check test pipeline. So all of the ones with green dots, the tests were passing so far. The one with the red dot, there had been a failure at some point on a voting test. but all of the tests hadn't completed running. So once all the tests completed running, then the logs go back to the patch, and then the developer is able to assess whether they've got more than one failure or just one failure, because all of the logs will be available to them. In the gate column, you'll see a line, and we call that a subway line. Jim? Is that what?
Yeah, sort of a subway graphing. It's based on the subway graph in the Git program for visualizing Git.
Okay, all right. So it's a subway graph, because the gate queue is the queue that you have to pass just before you're merged. And the way the algorithm works is that rather than testing each patch individually, so if we had 3 patches, if we were doing them individually, 2 would have to wait while we test this patch. And if we merge it, then we have to spin that up using the just merged patch to test the next one. And so what the algorithm is, and it's Zuul that takes care of this algorithm, what the algorithm is that we test all of the patches together, and as long as they continue to pass, they stay in that queue. And there's the terminology is the nearest non-failing item. And so as soon as there is a failure, and see this branch here right at the bottom, I don't know if you can see it or not, yes? The test just below this one, which is cut off on the slide, would be failing, which is why we have the branch. So the one that's failing, it still has to run because those logs have to be returned to the developer so that the developer can assess what's happening with their patch and why it didn't get merged, so that they can do what they need to do to fix that. But the one below it would still be in the subway line because it's passing. So what our algorithm does then is that it has a way of assessing which patches have the ability to merge because the tests are passing and which ones don't. And as soon as it recognizes that it doesn't, it moves it aside and has a specific line, the subway line, tells you which patches are likely to be merged and which ones have moved aside because of a test failure. Does that make sense? Okay, so knowing how to see that helps you understand if you're looking at your patch, let's say your patch is the third from the bottom, knowing whether or not your patch has a chance of passing. Sometimes, especially if you're in a time crunch, you need to know as soon as your test is failing so that you can make an adjustment. Oh goodness, okay. I only have 5 minutes left, so I'll move along. With Gerrit, there's some things to do with Gerrit. As soon as you clone your Git repo, because you're going to be developing on it, my recommendation is obviously take a look at your Git config and make sure that you've got your name and your email in there, because Gerrit will care because both of those things are needed for your patches. Use Git review. Somehow or other, there's a small pocket of developers who are not using Git review. And so if you're talking to somebody and they recommend that you don't use Git review for submitting patches to OpenStack, don't do that. Use Git review, because what's happening is that their patch is being pushed to Gerrit, so Gerrit knows about it, but Gerrit doesn't know about the parent. So the patch will never get merged because Gerrit doesn't know about the parent, and how they got this patch into Gerrit, they couldn't have done it through using Git review, and so these people will never get their patches merged because they didn't use the tool that we provide using Git review. Git review S sets up your remotes. So as soon as you get a repo, run git review S, and that creates remote branches that know about Gerrit, where our Gerrit is, and so that you can submit patches to that. You can download a patch using git review -d and the patch number. And you can also select a specific patch set as well. But you have to have those Gerrit branches in your Git repo in order to be able to run that. Don't use draft. Draft is an option with Git review. Don't use it. And the reason for that is that people use it in order to keep something between a couple of developers or have permissions for just a few people to evaluate the patch in the initial stages. But further on down the line, when you're ready to merge it, there's problems with merging, rebasing, and some of the other Git actions if the first patch set was a draft. And so we continually have problems with this. So now we're at the point, draft is still an option, but we're recommending that you don't use it. Use work in progress instead. So when you use the GUI for Gerrit, for each review, there'll be an opportunity, there'll be a work in progress button. The work in progress button is a signal to reviewers that you're still working on your patch. You want people to look at it, or it's a way to save it. So that you push it up to Gerrit, you have it as a work in progress, and then should something happen to your local development environment, you can just pull down the patch and keep working on it. Git.openstack.org is where all of our repos are. Elastic-recheck is one of the tools that we use to evaluate how our gate is failing and what bugs our gate is failing on. So if there are jobs consistently failing on the same bug, we have the capability of evaluating the logs, and if we see a recognized bug, Elastic-recheck will leave a comment on your patch saying, we think you hit this bug, and here's some recommendations. The one thing I will encourage you to do that, it will tell you to use a syntax recheck bug and the bug number as a comment to your patch in order to make the tests run again. One of the things that we're finding in the community is people are doing that, and they've got code that might actually be making the bug worse, and people are forcing it in by using recheck no bug, and so you finally, if it's an intermittent bug, if you run the test 10 times, you can get it into the code base, but what you've done is you've made the bug worse. So if you keep hitting the exact same bug, please go through all of your code and see if you can edit it some way so that you're not hitting this bug, and certainly make sure that you're not making that bug worse. This is a graph that is on the Elastic-recheck site, and Elastic-recheck does not have a link to anywhere else. So Elastic-recheck is status.openstack.org/elastic-recheck. There's no link on the status page to get to Elastic-recheck, but if you know it, you can find it. One of the items on this is a graph of gate failure rates, and it's a little hard to read right here, but that's how we're doing. Sometimes we have had up to 50% gate failure rate, and we're rarely down at 0. But sometimes we can get as low as about 12 to 15%. So seeing where we are with our gate failure rates, if you're pushing a patch and you're hitting a lot of problems with it, come on over to Elastic-recheck and see how the gate is doing. There might be a job that's having a problem with a dependency or a requirement that changed versions. And no matter what you do to your patch, it's not going to pass. So come on over here, take a look, and see what's happening at Elastic-recheck. There is another gate status page, and this is at Not My Name's website, and that's gate_status.html. And you probably have about 2 minutes. Does John have 2 minutes?
Maybe a little bit less.
A little bit less? Minute and a half? So John is going to talk about this slide, which he created. Oh, sorry. Let me give you a microphone.
Hello. Anita asked me to go over what does this mean. So there are, notice in the bottom left-hand or bottom right-hand corner, there's a list of 6 gate jobs that we have. Those are kind of small there, but those are 6 jobs that are run as a common, pretty much common to just about every patch in any project. And these are specifically gate jobs. They have to pass before a patch can land. So the purpose of this is quite noble. Let's make sure that we have everything integrated just fine. The problem is, sometimes there are some non-deterministic bugs that show up sometimes, and So the nice thing is that we've got graphite hooked up onto all of the Gerrit stuff, and so we know how often things are passing and failing. So the thin lines that are kind of the stair steps coming across there, it's bucketed into 8-hour time chunks, and I think it's currently it's a 3-week graph. So you can see that we specifically calculate within this 8-hour period, what was the percentage chance that this was going to, or what was the actual computed pass rate on here. So let's say, yeah, it's 85% pass rate or something like that. So then the bold red line is really is the interesting thing for me, and that is the fact that if you multiply those percentages together, what you have is these, if you have a perfectly good patch, it doesn't matter what it is, but let's say it's perfectly good, it does everything right, there's no bugs in it, everything's good, and it's the top of the gate queue. Then at that point, looking at the current patch chance, or the gate pass chances, you can calculate what's the likelihood that your patch is actually going to land. And that is what the bold orange line is. And you can see that sometimes it gets rather embarrassingly low. Because the point is, if you've got 6 things there, and each of those has a 95% pass rate, multiply that together, and it's actually a shockingly low number of what the problem is, what the patch chance is. And what's really bad, that's the thing at the top of the queue. If you remember from Anita's thing earlier, and as of right now, you can see we've got a very deep queue of over 50 things in the queue. So what's the likelihood that all 49 things ahead of yours are going to pass? And basically, you can see that it's not going to happen without some sort of gate reset, which means it has to start everything over, which essentially goes into you've got hours for your patch to land. The orange line that goes across there is the moving average for 1 week. I believe, yeah, 1 week moving average of that bold red line. And then in the shaded at the bottom is the current status of how many patches are in the gate. There's an average number of things in the gate for that 8-hour chunk, which you can see just over the last couple days, it kind of spiked up because they are working on fixing that because there's more Jenkins boxes now.
So that basically, I believe, is my time. So thank you very much. And do I have time for questions?
Probably not.
Okay, I don't have time for questions. If there is anything that you would like to know about, you can come and find me afterwards or at a break, or I'm around all week if there's anything I can help you with. Thanks very much.